So our second speaker today is speaking in the Paul Hemke series of lectures. Just to give a little history to understand the nature of this lecture series. They're named after Dr. Paul Hemke, who received his doctorate from Johns Hopkins in 1924, after which he went to work at NACA Langley, followed by a tenure with the Guggenheim Fellowship in Cambridge, which gave him opportunities to work with people like Prandtl and von Karman. In 1936, Dr. Hemke came to be RPI's first head of aeronautical engineering, where he oversaw a lot of development in the program here at RPI. In this lecture series, we have a number of distinguished speakers. Most recently, we had Dean Alec Gallimore, the University of Michigan. And today, we have the honor of listening to Mr. Jeff Singleton of the U.S. Army, who is the Director for Technology there. Mr. Singleton is a member of the Senior Executive Service and now serves as the Director for Technology, where he directs all of the basic, applied, and advanced technology development research for all Army laboratories, research, development, and engineering centers. Please join me in welcoming Mr. Singleton.
To RPI to give the Paul Hemke lecture. I started my career at NASA Langley, so to see that Dr. Hemke was also started his career at Langley Research Center is it makes us even more honorable for me to actually give this lecture in his name. If you have ever worked at a NASA center, it is Mother Langley, because we are the birthplace of all of the NASA centers. And it's a little bit of a rivalry between all the centers, but I am very proud to have spent my formative years there. The other thing I want to say, a few things before I actually get into my talk. This should be, it's a little bit of a different talk. I was a researcher for a very long time. One of my proudest achievements, which actually didn't make it onto this chart there, is that I was a team leader for the quad tilt rotor test at Langley back in 2006, and won the Howard Hughes Award from the American Helicopter Society. And that's it's something that I am most proud of still to this day for my career. It's one of the pinnacles that I think we achieved, demonstrating technology for rotorcraft and vertical lift. But my talk today is more about probably a little bit different, because I have not been a researcher for 10 years. I've been a suit. I'm a headquarters guy, director of basic research for most of those 10 years I've spent at headquarters. So I spent a lot of time at universities, a lot of time talking to students, to university professors. Now I'm the director for technology, so I manage all of the Army's basic, applied, and advanced technology development research. From my perch, from my perspective, I am a matchmaker. I love going out to visit universities and see research in the field, research in the labs, research in other services, because I like to put people together. And so I implore, the biggest takeaway I want you to hear from me today, and it's not necessarily in my talk, but you as researchers, you as professors, when you come to the Army and give proposals, tell your story. Don't tell my story. Don't tell me it will save the world and make bread lighter than air. Tell me what technical achievements you are working on, what innovations that you're bringing to the table, because that's important. You are the technical experts. You know exactly what you're doing. So tell me, where is your breakthrough and why it's going to make a difference. As part of my talking to university partners as well as my wife, I have a couple of sayings that I really enjoy, and I make all the time.
Sorry, I just need to increase.
I make all the time, and unfortunately my wife tells me you should never say that, because I always tell students, every time I get this opportunity, stay in school forever. School is not the real world, and it is a fantastic place to be. Now she always tells me, oh no, they gotta work, they gotta graduate. It's like, no, that's not what I mean. Just maintain that lifelong love of learning, because that is what has driven me. It's what drove me out of the lab and into the Director for Basic Research position I took at headquarters, because it allowed me to learn about more than just aerospace engineering. It forced me to learn about neuroscience and medical science and physics and quantum effects and electricity and material science. That has propelled me to what I truly believe has been a very fortunate and wonderful career. So stay in school forever. And the second thing, and Mike touched on it as well, but I want to expand on it a little bit. There's invention and there's innovation. So invention is turning money into ideas. And that's what the government kind of does a lot. Innovation is turning ideas into money. And that is exactly what's driving this industry today. So my talk is kind of framed in 3 segments. It's broader than just aerospace engineering. It's broader than just vertical lift research. I want to tell you where the Army is today, across the board, because that is important so that you understand context. In the middle part of my talk, I talk about history. I am an engineer by education, by training, by personality. I came to an appreciation for history after the fact, after I got out of school, after I started visiting labs and peoples from other countries and other countries. I have gained a much stronger appreciation for history. Our engineering curriculum does not allow us enough time for our students to actually branch out and study that. So the middle portion of my talk is a little bit about history. The last portion of my talk is where I get to the innovation piece. So bear with me. It's a little bit disjointed perhaps, but I do want to tell you, I wanted to tell you my motivation before I launched into this talk. So the Army today, and for the last 15 years, 16 years, we've been fighting around the world, more than 140 countries, mainly counterinsurgency. But the world has changed, the paradigm changed. So now the National Defense Strategy really talks about how do we actually operate in a world with near-peer great power competition. So that came forth in the National Defense Strategy. There is an unclassified version which you can read, which is important. Again, it provides context. That was adopted whole cloth and incorporated because it talks about the modernization of the Army. Again, we've been fighting in Iraq, Afghanistan, counterinsurgency for 10 years, chewing up equipment, putting a lot of ideas out in the field. A lot of technologies and capability went straight from the lab into the field, like the mine-resistant ambush protectant vehicle, the MRAP, and there are dozens and dozens of variants out there, not dozens and dozens, just dozens. But how do we sustain that equipment? So a lot of equipment has gone out very quickly, but it was targeted at a counterinsurgency environment and not on our home turf. We always play an away game. But now, we're going to be, the world is an environment where we're not going to have air superiority writ large. We're not going to be able to challenge the great powers. And that's not a political statement, that's just a fact of if you have to operate a military and protect your national security interests. We have to be able to operate in certain environments. And so the Chief of Staff, General Milley, distilled it down into 6 modernization priorities for the Army that nest directly into the National Military Strategy and the National Defense Strategy. And those are in priority, long-range precision fires, and I'll describe these in detail as we go through. The next generation combat vehicle, future vertical lift is a priority. The network, communications to me is the largest challenge. And then air and missile defense, how do we protect our assets? And then soldier lethality. So in the Army S&T, and I'm the S&T guy, right? 6.1 through 6.3 in Army speak, basic through advanced technology development. We have undergone over the last 2 years very significant realignment of the S&T programs. We moved about $2.6 billion, and that's, even in the government, that's a lot of money, to focus on the modernization priorities. And the goal is actually, an ideal goal might be to have about 80% of our budget focused on those modernization priorities. But about 20% needs to be for the true innovation, things that will change the paradigm, change the equations of the 6.3 and 6.4 accounts. So that's when you're really starting to demonstrate technologies that can be picked up by our industry partners and actually produced into, gone into programs of record. At the basic and applied research levels, which is where this research center lives, then really it should be about 60% of our funds should be truly looking for the next capabilities, the next breakthroughs. But about 40% of that too should support directly on the modernization priorities. So that kind of tells you how my world breaks down, because I am a strategy and policy and budget office. That's kind of how we break down our focus and where we want to invest our efforts. This comes directly from our Trade Act partners, Training and Documentation Command. Again, we're looking at great power competition, so they're looking to build an Army for 2028. In terms of, if you're at all familiar with acquisition programs, and you really shouldn't be. If you're a student, if you're a professor, yeah, you probably should be. If you're an industry partner, you know them well. 10 years is really, really close. To equip an Army in 2028, fielded Army, we're buying things today, or in the very near future. We're the next year or two. We're moving into production and development. But we're going to do this for the Army specifically. We really are starting to take on manned and unmanned concepts. Cost and sustainment is a big driver as well for our weapon systems. Sometimes you may have heard multi-domain battle, multi-domain environment. All that means is ground, land, air, sea, space, and cyber. Those are the domains of operations. So how do we get there? Again, I've walked through the investing in the modernization priorities. My boss, who is an Assistant Secretary of the Army, Dr. Bruce Jetty, he has also come up with some technology focus areas, which are very important to us. These include ultra-secure communications, including quantum effects, beyond just quantum computing and quantum cryptography, but how do you get the sensors for the timing? Timing is especially critical. Artificial intelligence is going to be a big driver for us. Virtual reality, particularly as it pertains to augmented reality and training environments. Directed energy, energetic materials, and ultra-design materials. We started a few centers a few years back, materials, multi-scale modeling materials, materials by design. So if you can manipulate materials at atomistic and molecular scale to get the properties you want in a real object, that would be very useful. A mouse that turns green in the presence of hazardous chemicals or explosive materials, or when it's lased with a non-visible light source. Those are the kinds of things that he wants to focus on. So now I just want to walk you through each of the modernization priorities and call out a few things. Unfortunately, I'm at the age where I'm bridging between reading glasses and non-reading glasses, so I'm trying to do this without flipping my glasses on and off, but we'll get through it. Long-range precision fires. Why is that a key thrust for the Army? It's because, again, we're going to have to go and operate against a great power competition if we have to go into certain areas of the world. And how do we get there? We have to open up a corridor through a anti-area, anti-access, anti-area denial capability, A2AD. So we're not going to have air superiority. We're not going to have a network. We're not going to have GPS. We're going to have to open up a corridor to get into wherever we may have to go. To do that, we need long-range fires. Strategic fires, which is very long range. Tactical fires, which would be within a theater, within a county, let's say. And then close fires, which would be very close combat, 10s, 20 clicks. So we have laid out an effort, lots of efforts, and this is actually fairly far along, demonstrations to actually demonstrate the capability in each of these arenas. But again, we want to extend range. We want to change the cost equation. Firing a shell is much cheaper than firing a missile. If you can fire a shell farther, an artillery shell, with some terminal guidance, then you can change the cost equation. And so that's very important. So advanced energetics, again, that comes back to materials by design. You get into the materials properties. And then finally, being able to, again, because we're actually shooting quite far, then be able to maneuver cross-domain fires, cross-domain maneuvers. Again, the goal is to provide extended range with increased capability to support maneuver, to support our forces' ability to get in through a corridor. Next generation combat vehicle. Again, this is where autonomous ground vehicles are really playing a role. You can save a lot of weight. The armor, a main battle tank, an Abrams battle tank, is pushing 80 tons now, 70, 80 tons. If you can take a man out of that or a crew out of that, then you need less armor to protect them. You can cut the weight by a substantial amount. Needs to be operated autonomously, teleoperated, as well as have active protection systems. Eventually, we'll get to the point where they need to have thermal management and power systems capable of doing directed energy on a ground maneuver platform. Right now, that's a really difficult challenge. But we want to advance the capability for our next-gen combat vehicle. We haven't had a next-gen combat vehicle in quite a while, just like we haven't had a next-gen aircraft in quite a while. Now, future vertical lift is actually the third highest priority, but I saved it for last because I want to launch into a talk about that. But I've talked about the network. The network's a real challenge. We're going to be operating in places where there are not cell towers, or if there are cell towers, they're jammed. We're going into places, the Army's going to have to operate in places where there is no GPS. And I tell people, oftentimes people will propose to us something that will take advantage of being able to use different frequencies to get around jammers capabilities, or hijack a signal from something else, or have a ground station that will augment GPS to boost it locally. That's not enough. We truly need to be able to have systems, and for air systems as well, that can fly with no GPS signal, with no network. That leads into our artificial intelligence and autonomous capability without a network. Timing is assured PNT, assured position, navigation, and timing is often a concern, and it's a major effort. It's one of the cross-functional teams in the Army right now. But it's not necessarily the position and navigation. We can kind of do that. Timing is the one piece that's really critical. If you have to do multi-domain operations from a widely disaggregated and disparate forces, being able to operate in synchronization with critical timing is a very big deal. And so to get to that, you get beyond chip-scale atomic clocks. You have to have atomic clocks that you don't have to synchronize for every day. You have to be able to operate for 30 days or more. That's really pushing the technology in quantum effects. Network is a huge challenge. Again, with long-range precision fires, we opened up a corridor. With a next-gen combat vehicle, we've actually started maneuvering forces into the theater. With future vertical lift, which was the third priority, you also start carrying forces and troops into the theater. The network has to exist in a GPS-denied environment with jamming and contested environment. Air missile defense, now we have to protect our assets. So we have long-range fires, we have to be able to protect those assets. How do we do that? We do that through active protection systems. We do that through cyber and electronic warfare to jam missiles, to spoof signals, inbound or incoming signals. We also do that through directed energy. And so we have a couple of demonstration programs. We put a 50 kilowatt laser on a Stryker, a tactical vehicle, to demonstrate the fact that it could actually take out counter UAS systems, rockets, mortars, artillery. Plan to move that up to 100 kilowatts because that's about where you start to get some true effectiveness in defending an area or a base. There are other elements of DoD that really want to push much higher, but you get into some technical details with technical problems with thermal blooming as you shoot a laser through an atmosphere. So there are a lot of considerations for how you actually get directed energy on a battlefield. In addition to the fact that you have to have clearance of fires because you can take out your own satellite assets. So there are some policy questions dealing with directed energy, high-powered microwaves as well, that are a challenge for the Army. And soldier lethality. Our soldiers haven't really, their body armor hasn't changed much in the last 15 years. They're the squad weapon. In fact, I saw an article just in the in early bird kind of thing this morning. Had the main rifle since 1953, I believe. And so the squad weapons, body armor, load-bearing capacity, not exoskeletons, although we are testing exoskeletons for their effect on the human body, human performance enhancement. Those are the types of things we're interested in increasing soldier lethality. Here's where virtual reality also plays a big role, because training, the Army has 500,000 in the regular Army and another 500,000 in the National Guard. So about 1 million people we have to train pretty much every year. So how do we actually effectively do that? If we can get to a synthetic training environment, that would be a much more cost-effective way of doing business. So now I want to come back to future vertical lift. We haven't had a new platform in quite a while. We would have had Comanche, but it ran into some technical and programmatic challenges, and so it was canceled. The current thrust we've been working on, and I'll talk a little bit more about it later, but I want to be clear that we had the Joint Multi-Role Technology Demonstrator. It started 5 years ago or so. Have 2 aircraft, two companies that are truly technology demonstrators. DARPA also had some programs, and I'll talk about those a little bit. But the main thrust here is the lines of effort now that the Army is pushing forward and getting near to program of record is for what was called CAPESAT 1, which is now the Future Attack Reconnaissance Aircraft, FARA. Some will say that the future is now, so it's just the Attack and Reconnaissance Aircraft, ARA. There's also CAPESAT 3, which is what the Joint Multi-Role Technology Demonstrators class are in. Those are, that's the long-range assault aircraft, the Future Long-Range Assault, FLRA, which also might be just the long-range assault aircraft, as well as unmanned systems, UAS, unmanned air systems. And again, the real goal here is to extend reach. Now, I've been an Army researcher for more than 30 years now. The technologies I worked on as a researcher was always, you have to buy your way onto the aircraft. And I did research on tilt rotors. It was a harder model. It was the hardest, to me, it was the hardest problem in aeromechanical stability, air elasticity to work on. So I borrowed a model from the Navy to work on that. But the Army was never really interested in speed, or at least speed could not buy its way onto the aircraft, right? It was conventional aircraft, the Black Hawk, the Apache won the day. They felt the need, they filled the requirements for the Army. And that works very well when you have air superiority everywhere. There's another concept which you might not think drives needs for aircraft, and that's the golden hour. The golden hour is how long a person can survive a traumatic injury if they get advanced medical care within an hour, then they probably will survive. That paradigm actually drives how the Army operates. It drives the range that our soldiers can operate in the field, because they have to be within an hour of evacuation. From a casualty to get back to a trauma care is an hour. And I've been told this by a 3-star general in the Army, aviator, Jim Richardson. So it's not a random thought, it's how the Army operates. But now if we can demonstrate speed or endurance, we can increase that range. You can't increase the golden hour. I talked to the medical researchers, the golden hour is the golden hour. So you have 2 options. You can increase the speed with which you can get someone, speed and range with which you can get someone back to advanced medical care, or you push advanced medical care forward. Having an aircraft that can actually travel farther, faster, allows a greater range of operations for the Army, the U.S. military. So that's one of the key drivers that we've actually opened up some new opportunities for innovative designs. The other area which is really taking off, pardon the pun, is unmanned aircraft systems and autonomy. And the ability to partner with a pilot or a manned aircraft or a manned ground vehicle. And my concept of this is it's not just a wingman. It's not an unmanned asset for for an Apache or for a attack and reconnaissance aircraft. The unmanned air asset could also be a wingman for a ground vehicle or a ground troop, and vice versa. An unmanned ground vehicle could be a teammate for an air asset. But we have to understand the behaviors. And this is not the swarm you saw at the Olympics. This is not, massive swarms that are pre-programmed. Swarms have to actually, and unmanned air systems actually have to think. They have to respond to their environment. They have to respond to the mission changing and think intelligently and enable our manned troops to actually be more effective. It can't be a burden. It can't be a teleoperated type of thing. It has to be truly autonomous, truly artificial intelligence enabled. Okay, so that was kind of where the Army is today. That's the driving forces across all 6 modernization priorities. We have 8 cross-functional teams, 1 for each of the modernization priorities, as well as 1 for a synthetic training environment and 1 for our assured P&T. So that's where we are. So now I want to go back to history and where we came from. And again, it's a small community. Aviation is always a small world, right? So Mike and I have obviously stolen some of the same quotes and some of the same pictures. That's a good thing, at least from my perspective, I think it is. So where do we get inspiration for new ideas? Inspiration for innovation. And, for us in vertical lifts, it goes back to Da Vinci and Otto Lilienthal. We can invent it, we can build one, but to make it actually fly, make it actually work, is everything. So where do we start? We started with Igor Sikorsky, at least in a practical sense. His H-1 and his S-2. Does the S-2 look familiar? Counter-rotating coaxial rotor system. About 30 years later, he immigrates to the US. He actually starts his company and successfully flies the VS-300, about 1940. So about 30 years later, he made a jump and was able to make that work. Foreshadowing, that's not necessarily a good story. Another 30 years later, we've gone through Korea, we've essentially, even to the Black Hawk and Apache. From my perspective, and I apologize if my perspective is wrong, but it is my perspective. Government, particularly defense, has been driving the innovation in vertical lift. So we came up with the Black Hawk, long-range assault, the Apache, the attack helicopter, very capable platforms. We have upgraded them continuously. But again, they're about 30 years old. If Comanche had come online, we would have had the new platform 30 years later. So another 30-year jump. I mentioned earlier, I talked to a lot of universities, a lot of students, so I like to throw in history every once in a while just to put things in perspective. Apple Computer, April 1, 1976. The computational power I left on my desk, the table over there, and your phone it's more than a supercomputer nowadays. The computational power we have is just incredible, and it's ubiquitous. As an engineering student, also think about the future. We launched Voyager 1 and Voyager 2 in 1975, 76. 77, I'm sorry. We're still communicating with Voyager today. It is outside our solar system. It's in interstellar space. The engineers that designed that designed a communication system into it that we can still talk to today. That is some forethought. And it just highlights the capability, what we can do if we really think about it and put things together well. That's why the Chinook's going to fly for 100, it's going to be 100 years. It's going to be 100 years. B-52 is flying for 100 years. Not that we necessarily want that, but we can do that. So our history is important. Look at what we have done in the rotorcraft industry, and look for the innovations. Again, I mentioned that DoD has been driving innovations. So here's the current. Here's the two JMR technology demonstrator aircraft, the Valor and the Defiant. Apologies to Sikorsky. Counter-rotating coaxial rotor, advancing blade. Sort of like what Sikorsky himself thought of in 1910. Government has been driving innovation. But is that really current? Is that really innovative? You know, we had when the LHX back in 1984, Bell had the BAT. Sikorsky had the LH2 concept and the advancing blade concept as well. We have flown these. We have demonstrated these. We're demonstrating these again. So that's what I really liked about. So the demonstrator aircraft, again, we're pushing out speed, mission radius, I've talked about that, range, operating conditions, higher and still, or hotter, higher and hotter. DARPA has programs. So I think we've actually demonstrated, particularly over the last 10, 15 years, we've been able to demonstrate at subscale and test cases and experimental aircraft some truly revolutionary in technologies. Active controls in the rotor systems, stability augmentation, active flow control, multidimensional or multifunctional structures, structural health monitoring systems, composites, self-healing composites, nearly full flight authority, individual blade control. So the research that the government has sponsored, the Army has sponsored, has enabled a revolution in rotorcraft. The Army itself is no longer, because of requirements, because we have specific needs, we're not truly driving that innovation anymore. Mike just showed you a very thorough listing of all the innovation and innovative concepts that are going on in the commercial sector. So from my perspective, the commercial sector is truly driving the innovation. We still have a need for all of this technology and all of the bright young minds to continue thrusting this forward. Because the paradigm has changed. Now I believe that the Army will leverage what commercial industry is showing can be done. So don't take my talk as depressing. It took, from a big platform, Army perspective, we kind of moved in 30-year jumps. We're just about to launch our next platform. So the next platform the Army buys may not be for 30 years from now. Don't worry about that, because commercial industry is really driving where we're going, and these capabilities are exploding. So hopefully it's a good news story, not a bad news story, but sometimes I spook people. So now I want to shift again, and maybe move away a little bit from aerospace engineering in general. Because I like to just, again, I'm a matchmaker, I like to lay out what are the possibilities and make people think a little bit differently. So where does it start? Where did we start? It starts with people who are not afraid to answer the question, why not change the world? So you are the ones that should not be afraid to answer the question, why not change the world? A couple years back, in my office, we started looking for future trends. What this does is, let me orient you to this chart for a little bit. We looked at technology areas, and we had a contractor, a university, go out and look at a multitude of future-looking, future-thinking publications and reports. So when you see 79% concurrence, what that means is that 79% of these 20 or 30 different publications and different future-looking organizations concurred that 3D and 4D printing was going to be a thing for the future. So, and to be honest, I forget what the 8% share means, but the concurrence is the big thing. And so now, how does 3D and 4D printing play into what we might be doing here? Well, 4D printing is just something that can change over time. So 3D printer, everybody sees 3D printers, you can do something. With 4D printer, you print a material and it can self-heal, it can change its properties in different conditions, so it's 4D printing. But imagine what you can do with 3D and 4D printing. Now you can print, you can print replacement parts anywhere in the world. If we develop the technology far enough, you can print parts as needed from indigenous materials. That will transform military logistics. That will reduce the cost equation for how we operate. It will also allow for commercial entities to go into developing countries as well and print what they need to. Material science, new polymers that work in 3D printers. We can now print metals, we can print explosive inks. So there's just a world of opportunity and things we can do with 3D and 4D printing. And imagine what they can do with UAS systems and particularly lightweight UAS systems. Analytics, we are awash in data. I was in a meeting yesterday talking about how much data we're ingesting on a daily basis. It's hundreds of terabytes, exabytes of data we are ingesting from a certain operation we're doing in the field. So how do we get a handle on that? Artificial intelligence, machine learning, the understanding the maintenance rates, the repair rates on aircraft, on ground vehicles, on understanding biometric data on humans, being able to analyze that, ingest that data, conduct the analytics so we can actually figure out that I'm about to pass out because I haven't eaten in 6 hours, even though I look like I'm fine. Or I am slightly dehydrated and I can't go on a mission. I'm not the best person to do that. Or this aircraft I need to replace the transmission in 20 hours. Rather than do a scheduled maintenance, now I can do the analytics to figure out that, okay, it'll last another 100 hours and I can keep things flying. So analytics is really going to be important for us in the future. Some of the neat things in there, we talk about natural language processing. Again, with autonomous systems or unmanned teammates, the ability to give a direction to I view it as like being able to give a direction to a dog. If you can tell your dog to go fetch, you trust it. Your dog's going to go fetch whatever the object you're trying to get it to do it, if it's well trained. We want our unmanned teammates to be well trained, to understand spoken and nonverbal commands as well. So natural language processing from multiple different dialects and voices and sounds is extremely critical. I mentioned machine learning. I mentioned visualization because of synthetic training environments. Visualization, how good does it have to be? It will play a key role in being able to train not just with someone in the room here, but with someone halfway around the world, and we can share knowledge and train together. This one scares me a little, again, because yes, we have mobile and cloud computing. It's ubiquitous as well. There's robust wireless networking. Takes a lot of power, takes a lot of energy. The data centers suck down a lot of power. Lincoln Lab set up a supercomputing center in a box, essentially a container box, but they moved it out somewhere out near here, western New York or western Massachusetts, for the cheap hydropower. So power and energy, the amount of power that's being sucked down just due to the cloud computing is enormous. They talk about for defense that we actually are coming to depend on cloud computing, but that's where it scares me. Because again, I tell you, we're not going to have a network. We're not going to have fat pipes to go back to a home station somewhere. So we actually need to move high-performance computing very far forward to the forward edge of the battlefield. If we can get a true supercomputer petascale computing, exascale computing in a container box and ship it to a forward base, that would be a extreme technical advantage that we can have. The Internet of Things, again, the Internet's not always going to be there, the bandwidth's not always going to be there, but literally everything is a sensor. Every soldier is a sensor, every device is a sensor, everything is a node on the network. It can be addressable, it can tell you that it's tired, it can tell you that it's out of power, it can tell you that it's in the presence of a poisonous chemical. So how do we take advantage of that? How do we take advantage of that in an aerospace system when you're managing, when you have a swarm of thousands upon thousands of objects? What are the opportunities there? I don't know, I can only imagine. Human augmentation too, I was watching something on ESPN. Apparently drone racing is a real thing now. There's a drone racing league, DRL. Guys are really incredible. They're flying through inside of a casino in Las Vegas with headsets. When's the next, but they had to do still do the joysticks and do the thumbs. When's the next step? Human augmentation. When do we actually get a port into the brain that can pick up nerve signals or read your thoughts? To me, I think that's exciting. Some people that frightens, but human augmentation, not just in terms of physical strength or endurance or pharmaceuticals, but actual human-machine brain interfaces is what I think is find really exciting. And then autonomous systems. I've talked quite a bit about them. Some of the other things that to pick up here is, again, it's the human-agent interaction. So how does a human talk to an AI? How does the AI track what the human's perceiving? In a training environment, we can now, you have intelligent tutors that understand that you're comprehending the information you're receiving, or that you need to go back and pass through the lesson a few more times. Agent-to-agent teaming is also, I don't think we even understand what that really means yet. If you have an AI that's defending your network against a cyber attack, how does it pass information to a different AI on a different network managing a logistics supply chain? So agent-to-agent teaming, and then where do we trust that? Skynet is real. May not be here yet, but that's an ethical question we have to answer. The intent is to use robotic systems to help reduce the burden on the soldiers, but there are some serious implications there that we really need to think through in quite a few areas. So the title of this is where does it end? But it really gets to be where does it begin? Which one of you will go out and sit on a park bench and think of the breakthrough which will impact the world, which will change the world? Charles Towns in 1951 went outside on a bench outside in Washington, D.C. and had the aha moment where he developed the theory for the maser, which became the laser. And without the laser today, we're in a completely different world. That is his grandson sitting on the bench with him, with the statue of him. So the question is not really where does it end, because I don't believe we're at the end. It started with an inspiration, an aha moment. With Da Vinci, it was Charles Towns. It starts with you and all your professors and all of us. And where do we go? Where do we go is the question. I don't wear a watch. I haven't worn a watch in 30 years. So I don't know how long I've gone. I like to answer questions. So with that, I will be happy to answer any questions and talk about anything else. And if you don't have questions, I won't be offended. It's a little bit of an oddball talk. Dr. Lewis. Dr. Lewis.
Hey, thanks, Jeff. Hey, having been in this business for some time with the Army, when I first got into this business, it seemed to me that that the intuitive thing would be to have commodity-focused research, a product that you were trying to research components into. But it seems to me that the majority of the Army's thrust in research is to have functional items that are researched. And if they happen to ever become applicable for commodity, then we transfer them into the commodity. Why do we have that philosophy in the Army, vice a very specific and targeted commodity emphasis?
That's a good question. So let me answer it, and I'll answer it in a few ways and a few times. I think looking from again, I was basic research for a long time, so I look at it as the functional areas kind of support multiple commodities. So I think they're both approaches. Because I started in Aviation Systems Command, which was a commodity research organization. In my history, I moved to ARL, which was a functional research organization. And so it is the need of the moment, I think, kind of drives that a little bit. But as well as the change in the nature of where the breakthroughs are. Because I'm a firm believer in the fact that the true breakthroughs are at the seams and the boundaries between disciplines. It's why I kind of wound up in aeroelasticity, because it's a combination of 3 different disciplines that drive that area. So I think that's kind of what it is. Is the balance right? I don't know if the balance is right between a functional type of approach versus a commodity type approach. It looks like we're swinging back towards a commodity approach with the 6 monetization priorities. I think it's just, I really think it's just there's a need for balance between the 2 approaches, recognition that both are important. Do we have it right? I don't know. I don't know if I really answered your question, but that's my belief. I do want to, you did remind me though of one thing. We talked about, most of the research here is about platforms, essentially. Platforms, rotors, aerodynamics, engines, controls. But a real big challenge for both unmanned systems and manned systems is being able to operate. The Black Hawk can't fly in today because of weather.
I would dispute that.
I'm with you, actually. I'm always surprised when a flight gets scrubbed because of weather, and I think, really? But the pilots have to fly. They have the rules, so I'm not going to seriously second question them. But I believe the Army has an effort on degraded visual environments, being able to fly anywhere, anytime, any place, any conditions. And so the mission equipment side of the equation is extremely critical and extremely important. Now, in aviation, we don't focus on the sensors, but they are part of the aircraft. And so I think that's a need for big Army as well. And we're working it, but maybe not as best we can. Yes, sir, Dr. Rosen.
Yeah, I want to congratulate your last comment about the importance of avionics and sensors and internal networks within the vehicles themselves. Most people don't know how much weight's involved, and aviation success in our business, in our vertical business, is hugely dependent on weight. For example, the Seahawk has 1,500 pounds of wire right now. It's just an interesting point. If we're going to move terabits of information in these aircraft, we're not going to be able to do it with copper internal networks. We're going to need fiber optic. We may, in fact, need wavelength division multiplexing, the kind of thing that components don't exist yet, exist in the telecom business, but not in our business. And yet we would spend tons of money on road research and not enough money on those kinds of things. So, and how do they influence the size of the aircraft? People say these aircraft are too big. One of the reasons they're too big is the size of the payload. In other words, if we can get these functions, these MEP functions, these avionics functions, into use common waveforms, whatever, find ways to get those weights down, we're going to find we have far more compact and affordable aircraft. I'll just make that plea. I sensed you got that because you said it. And it's one of the few times I've ever heard it said.
I think fiber is the way to go. Anything wireless, it's just going to be jammed or it's going to create interference somewhere else. And with the redundancy, you can't get lighter than light. So optical comms, optical computing. The other thing, on this thread as well, it occurred in ground vehicles for sure. I know it's probably occurred in rotorcraft and aircraft as well. Kind of design around the human. I think what we really need to do moving forward is design around the computational power that you can put into one of these things. I mean, Dr. Rosen talks about moving terabytes across the, inside the aircraft. But if you go to having sensors that allow you to fly in any conditions, communicate with an unmanned asset somewhere, then it's going to take a lot of computational power. And AI in a system takes a lot of computational power. So we almost need to and in fact, I think that's what Elon Musk did with the Tesla. He built the computer and then designed the car around the computer. So I think that's important moving forward. Yes, Mike.
Yeah. So a question and a comment. So industry is, waiting with bated breath for the solicitation for FARA, and you were saying that they're going to change the name?
I don't know if that's official or not. I mean, that was an internal building contact comment that someone said, no, because it is coming out now, why future? I don't know. The name for the FARA, Future Attack Recon Aircraft, I just heard a comment yesterday that it's not future, it's actually now, so it's just the attack recon aircraft.
Yeah, we're trying to track,
It's FARA. It's FARA. Sorry, that's just a FARA and Flora.
All right, and my question.
Cape Set 1.
Yes. So my comment, I guess, is that at and I'm sitting in the front, so I can read the tiny print on all those charts you put, which are had a lot of detail, and a lot of thought-provoking statement. But one of them was from the Center for New American Security, and it said the U.S. lost its monopoly on drones years ago, and now it's basically a commodity that there's so many other countries that are doing that. And I guess I just want to make the point that because the FAA restrictions until they're not even ready yet still. But because of the FAA restrictions, the innovation and the production, industrialization of drones, went to China and went to other countries, and so, the environment for having, the environment is very important for developing innovation, and going back to electric VTOL, for instance, the regulatory and the other. Not just the FAA, but all the different environmental or the ecosystem is so important. Anyway, I just thought that was a very germane quote on your chart there.
Yeah, I agree. In fact, didn't Dr. Lewis ask you about that? About the regulatory and all that? I think that was your question. That's one for the AHS.
I'd like to follow up on your comment about the Defense Department being able to be the leader in vertical flight in the past, because I totally agree with that. But it looks like civil applications, as we prove out these new missions and markets, that the private industry could become the leader in advancing the technology for vertical lift. And I'm just wondering the implications of that. For instance, let's say we really achieve just an ultra-quiet vertical lift capability, or we achieve self-forming swarm capabilities that can really do these massive distributed things. The Army, has been great at being a strategic leader in the development of technology in the past. But as the civil world in Silicon Valley creates this pace of innovation, which I think is almost certain to happen in vertical lift over the next 20 to 30 years, the Army has to go into a reactionary mode instead of that strategic leadership mode. And big institutions are great at long-term strategies, maybe, but not really good at reacting quickly and adapting and being agile. I'm just wondering, how is the Army, if this comes to pass, how is the Army going to be able to keep up? And how does it start to think of being an effective reactionary agency? Or do you see it differently?
No, I agree with you 100%. And that's why I say we really need to be in a position where we leverage what the commercial industry is doing. There will be niches, and that's why when I started this talk, I said, tell your story, because it's obvious that technology is spinning so rapidly these days that we could latch onto the wrong thing. So don't worry about telling us what capability to do. Tell the story. What is your breakthrough? Because we will have to choose from many, many options. And so if you're the expert, if you can't tell us what your story is, then it's just going to be lost and cut, and we'll move on. My other saying is because I think it is changing. Well, I have a couple of comments. Go ahead. You were going to ask something.
Well,
else
I was
first.
just wondering, especially like in the context of, like many of these things are ITAR, autonomous control of flying vehicles, or EAR restricted, or achieving, again, that ultra-quiet capability. Those things have been, in the past, they've tried to be regulated in terms of innovation so it can't spread, but it's like inevitable that it is going to spread. And in fact, the ITAR and EAR seem to be putting the United States at a significant disadvantage to other countries who don't have the same burden.
I would agree with you. Yeah, the regulations are, and the restrictions are a challenge. There are other challenges that still kind of mandate that we keep some and perhaps expand restrictions in other areas. What I wanted to comment on, though, is that, the Army is an institution, a long history. The Army Futures Command, which I hope everybody has at least heard of, I truly believe in the concept of Army Futures Command. We have to make it faster from ideation to actually fielding a product. And how do we do that? The implementation, we're working through that, and we'll see how that really goes. But the concept of actually shortening the time cycle to get technology into the hands of the folks who need it quicker is something we need to address. So my other kind of common phrase is embrace the insanity, because the time cycle and being able to deliver something and to make decisions and to move a large institution on the fly, the pace has become truly insane. But and it's still not keeping up with some of the cycles in certain technology areas that we're seeing from the commercial side. So, there's lead, shape, and follow. We really have to shape and follow a lot more these days, and focus the Army on the niches where commercial industry won't go without our pushing them. Easy one to call out there is armor. Armor materials is not a huge commercial market while there is an increasing market for protection, there's not, for true armors, there's not. And so, and for energetics, that's probably our niche as well. I'm getting suggestions that this might be a last question.
Well, okay then, but I don't want to make it an easy one for you. It seems like reaction time, where you invest, your armor is a good example. The thing that just I don't know how to get my head around is cybersecurity, and then more to the DoD, where there are industries investing in, I'll say, defensive cybersecurity. There's very little capitalization for offensive cybersecurity. Just your thoughts on cybersecurity and the OODA loop of having to do that, and how you're taking the lead on that.
I'm not sure that we're taking the lead on that, again, because the folks who want to do harm are, how do you move much quicker. But yeah, the cybersecurity, defensive cyber, defensive electronic warfare is a big thrust for us. It's part of the networks area. There are specialized folks that actually do that for all of the defense networks within the Army lab system. It's a challenge, it's a challenge with, because it goes all the way down to are the chips trustworthy? You have trusted foundries, not just, so the hardware and the software part of cyber is a big challenge. We are focusing on that. It does get classified real quick, but so I know I didn't answer your question. It is a recognized problem. It is threats we're facing every single day, and it is real. The threat is real. So anyway, yeah, it's. I don't know what else to add. I apologize. So I think that's it. Thank you.